All right. Good evening, everyone. Welcome to Tuesday evening's tutorial, the one you all know and love. So tonight we're going to look at a past paper from 2013, selected by the group of students that were here live. And we're going to go through the paper itself, and then we're going to go through the memo. Now, when I say we're going to go through the memo, we've got the code set already. It's already coded out. I'm taking the memo as is from that 2013 paper in order to speed things along, because unfortunately we don't have enough time to code out the entire thing in the session and me still explaining certain areas. So what we're going to do, and the students has already identified that they're struggling with the reading and writing to a file. Now this is a random access file practical. So the idea here is that we're going to go through the code, we'll look at the code, we'll explain it as we go along, we're going to remove it, and then we are going to do it. And when I say we are going to do it, I'm going to do it with your input as well, so that we can kind of see where exactly your misunderstanding is coming from or where your issue is. It's not just going to be typing out the code again for you. It's going to be me and you looking at this code and discussing, okay, this is what needs to happen next, why and how. So that you can kind of see what that train of thought should be when you're writing this paper. Now, one thing I want to point out before we start. When you look at your question paper, you go through your question paper thoroughly. You have more than enough time. There's 3 hours for you to write this paper. Now, if you've been doing all your practicals on your own, you've been doing this code, you've been attending our TUTs and our classes, you should have more than enough time to write this paper. Now, for those that are writing it out by hand, there is additional time. Remember, you do have the submission time, but please make sure you don't write unnecessary code. Make sure you answer what is requested and focus only on that. Fortunately, those that are writing it out by hand, you do need to maintain your, or make sure you maintain your speed at which you're going to write this paper, because if you start getting behind, you might lose that time. That being said, let's go through this paper. So, like I said, it's an SSA paper, paper C from 2013, written in October, late in the semester. Well, it's an SSA. So, generally, we had more than one paper there. On Friday, you might see more than one paper, so just be aware of that. Now, you'll be given an intro to this paper to give you some background of what's going on. So let's go through this intro and then we'll look at the questions individually. The University of Johannesburg is concerned with the attendance rate of their exams and would like to analyze recent statistics. They commissioned a company to capture the data before approaching you to develop the necessary application in Visual Basics. Questions should be answered in separate methods. Each of the questions must be answered within its function, subroutine, or event, such as button click. Now, please keep in mind that these instructions are important to note. Each question that we have will have its own function, subroutine, or event. And those are important things to note because it's not really explicitly defined down in the memo. You do get marks for it if you do lose marks if you don't adhere to this. Right. Sorry, my mouse is jumping here. When working with a file, you must name it the same as your project name with the file extension IFM. So there's the first important note we have is the file extension needs to be IFM. So when you start your program, you need to make sure that that file name is there and it's correct. For example, student number 201300001 sitting at computer number 10 will have named his or her project CO10 underscore student number, and then that would be the name of the project. The name of the file will be CO1 underscore student number .ifm. Now for you, you are just going to use your student number. Please make sure you're following the naming convention we tell you to follow. There's a reason for that. You may assume that the file will be saved in the local folder of the Visual Basics application. There's another piece of information, remember. You don't have to put down the directory if it's a local folder, which in this case it's going to be. You do not have to implement any exception handling. You may assume that no collisions will take place. Two important things. Now, keep in mind that this will apply Friday as well, because if you are asked to do a hash function, we're not going to ask you or expect of you to handle collisions. That's if you see a random access. Emphasis on if. So, files. The following question, A to D, must be completed within working with files. Failure to do so will result in the student being awarded 0 for the section below. Now, please make sure you read them, because if you don't use a file, you can lose a lot of marks. Yes, we will do that when we get to the place where we're going to use that. Right. Any code pertaining to the incorrect file type will also be given 0. We'll be strict, but we're not going to be that strict. It is advised that file-related code is developed in your form class. Now, we've been doing that ever since we started with files, and we're going to continue with that. All file-related code should be in your form class, which is when you add a button or wherever you initiate an event, trigger an event in the form itself, that's where you will handle your file code. So, question A, or section A of the paper. Locate the file uj.maxi.info.1b.st2.ssa.dll in your T drive directory. Now, we're not going to give you something like that. We'll probably just upload the file for you. Use it to instantiate an IFM exam object that will create the random access file that is capable of storing 15 of the following records for you. Now, important things to note here. This is a file given to you. We're going to give you a file. Use it to instantiate an IFM exam object that will create the random access file that is capable of storing 15 of the following records for you. So that object is important. Now, the following explains the object. ID. This is an integer value uniquely identifying the exam. So you can already see uniquely identify the exam, so that is going to be our key. The value is 0 if the record is empty. Otherwise, it should be a value from 1 to 1000. So that's going to be an integer, or if you really thought that far, it can potentially be a short as well, depending on how you want to handle it. But that can be an integer, can be a short, can be a string. Most of you will most likely use an integer here. Subject name. A string limited to 25 characters. Remember this. A string limited to 25 characters refers to the name of the subject. Lecturer name, a string limited to 15 characters, refers to the name of the lecturer of the exam. Number of students. An integer value indicating the number of students in the subject, number of students who wrote, an integer value indicating the number of students who wrote the exam. That is our object. ID, subject name, lecturer name, number of students who wrote. To successfully instantiate an IFM exam object, you'll be required to provide You'll be required to provide the location of your file. This will create the file and save the necessary records into the file for you. Should you not be able to do this, copy the file ssa.data.ifm into your local folder and rename it to the appropriate file name. See naming convention above. You will, however, not receive any marks for question A as a result. So the idea here is that you create this file structure, indicate that you're going to be storing 15 objects, and allocate those spots already based on the information you're given here. So, assuming everybody is with me there in terms of what is expected of us for question A. Then, question B. Using a grid, display the content of the random access file. So, simple enough. We read out the random access file and we display it on our question C. With a hash function, that given a record key will return a file byte position. So write a hash function. Brain freeze for a moment. So we need to write a hash function that will return a location for the file itself. I'm assuming that function will be given to us. If not, then we just use the prime number algorithm that we have shown you before. Write a function that will use a record key parameter to read the relevant record from the random access file. The function should return a record containing the data fields as outlined in question A. So write a function that will use a record key parameter to read the relevant record from the random access file. This is, are you answering the question? This is where we're going to essentially search for a specific value. Right. Then we have question E, create an interface called iCalculatable. This interface comprises of the property methods, number of students and number who wrote, and a string function evaluate attendance. The property methods are not editable. Now create a class called CExam, which has the following attributes: ID, subject name, lecturer name, number of students, number who wrote. We've got CExam has the following methods: constructor, string, or toString. That is our display. Generally, the default display function was always called toString. Attendance percentage, and then evaluate attendance. So those are just general class-based things that you should be comfortable with. So we won't be covering that. We'll glance over the code quickly, but we're not going to discuss in detail. Then we've got question G. Next, create the following classes, which inherit from CExam. The following table contains the additional properties and methods for the two derived classes. So you've got C practical exam, C theory exam, exam length, number of pages, and then evaluate entrance. Then you've got structure, and then evaluate entrance and constructor. So different parameters there. All properties above are integer with values of at least 1 and higher, defaulting to 1 if the value provided is invalid. Keep this in mind. It indicates that you need validation. All properties above are integer with values of at least 1 and higher, defaulting to 1 if the value provided is invalid. So we have validation there. Then using a single array, instantiate objects to store information on the various exams, number of exams, type of exam, practical or theory, exam ID, and other additional information not obtainable from the random access file will be input by the user of the program. Note, it is not necessary to make use of enumerations in this question. Show that the information has been captured correctly by displaying the details of all exams in a multi-line text box using polymorphism. So that will just simply be our once we inherit, we'll just output that once we read it into an array. Determine what the lowest attendance rate is, and display this attendance rate in a single line text box. Sorry, one of the lecturers don't understand that if I'm not responding, it means I'm lecturing. Right. Question I. Determine what the lowest attendance rate is and display the attendance rate in a single line text box. And simply just find the lowest min value and then output that into a single line text box. Easy enough. So we will also include a mark sheet as follows. Make sure you read this before you actually start answering your questions, because this mark sheet gives you some information as well. So let's quickly go through this as well. Description. You've got your design. Now we'll probably label it design. You need to make sure that your design is there. Everything is there. We generally output or list what we want. In this case, we'll probably just write design. You know what is in a design. You know what needs to be there. And you've got file related code. So that is now question A specifically. We have to read from a file, create this object, and then transfer the information into that file. To set up and create the IFM exam object. So we need to make sure that this object is set. Set up a random access file, including record structure. Display the random access file in the UJ grid. We've got the hash function that we need to use for the file related code, and a function for reading of record from random access. So pretty simple, read, object, hash function, write. And we've got our iCalculable interface, which we just need to define. Our classes, which is define methods and constructor, our derived classes, define methods and constructors, application of files, and object-oriented principles. So instantiation of a practical and theoretical exam object includes the access, or includes file access. Instantiate of practical and theoretical exam objects, including the file access. Also, that's code, that is correct, so you've got a correctness mark there. You've got display of exam information using polymorphism, so you've got the code and then how correct it is, and then display of the lowest attendance percentage code and then the correctness mark as well. So let's just look at this question. So we must include data even if no marks allocated for it. But in this case, you were actually given test data. It was given to you. So over here, you've got saa-data.ifm that contained data for you. You can probably just copy and paste that and rename it, but your code itself needed to set up that folder. Now, the idea is that the information will be given to you. Use it to instantiate an IFM object that will create the random access file that is capable of storing 15 of the following records for you. Now we'll go through the code, look exactly what is expected of you. We've gone through the questions. Now let's look at the application itself. Now, the first thing we're going to do, we're just going to quickly glance over the interface. So you've got your public, your interface, you've got your I. Remember, your interface is always starts with an I. Just a naming convention. The name, you've got your property methods there, and then you've got your one function here. Pretty simple, straightforward. I don't think I need to cover this in more detail than we have done when we did interfaces. I can't remember if you asked interfaces. I kind of think we did not. But make sure you can do an interface. It may be asked, if not in the main paper, then in the SSA. Then we've got our C exam, which is our basic structure, our ID, subject name, lecturer name, number of students, and number of students who wrote, integer, integer, string, string, and integer. We've got the constructor that will create those objects for us, or populate those instance variables for us. We've got a toString function that will return the output in a string for us. We've got our attendance percentage, which was defined for us. We've got a evaluate attendance, which is a must override function as defined in the question. We've got our number of students, which implements our calculatable number of students. So the property methods that were identified here. And then our valid value, that validation that was in bold at the bottom of the table. That's why I say make sure you read the entire paper from top to bottom. Don't skip anything. Then we've got a practical exam, which inherits from exam, and the addition is exam length. Then you've got a theory exam that has number of pages as its addition, and then you just have those overwritten values. Why is it a protected function, the validation? Okay, the validation is a protected function because you're writing it here, but we're using it in all of the derived classes as well. See example. All right, let me just get this back. So it's protected because we want to allow the derived classes to use them as well. Otherwise, you'll have to recreate it across the board. It could also technically be public because the validation itself just looks at the value and makes sure that that value, if less than 1, returns or is set to 1, otherwise returns the value. Because it only applies to an exam, it's protected because it's only this exam set that will be using this validation value or function itself. Right. Now, it doesn't state in the paper that it needs to be protected. As you can see, all properties above are integer with the values of at least 1 and higher defaulting to 1 if the values provided is invalid. Nowhere there does it say it has to be inside the exam, so it can potentially be inside the derived class as well. Just keep in mind that if you do that, you'll have code duplication or redundant code, which means you've got more than one code sets that do the same thing. So you can make it public, you can make it protected, it can be in the parent class, or if you really want to waste the time, you could potentially just have it duplicate in all the other codes. That's the same thing, and it fulfills the requirement here because nothing here says that it has to be inside the parent class. Always keep that in mind. Always look at what is asked and how it is asked. If it's not clearly defined, you can either ask us or you can assume what it should do. So if I am correct, the toString function is the same as the display function, and the difference is the toString function displays out the output in one string line, and the display function displays it line by line using environmental.newline key. No. So the toString function and the display function, exactly the same. No difference. We just used to call it toString. So the default name or the standard for a output of your class is called toString. We've just been using display because it's just a naming convention. It doesn't have to be called toString. The naming convention is to call a toString to output all desired information of the current class. You'll see that most of your custom classes and most of your known data types, if you write the variable name, there will be a .toString at the end, which will output the value of that specific variable. Almost every class has a toString function. All right. Now, we just briefly glanced over the class structures. Okay. So you don't have to worry. You can call it toString. You can call it display. If we tell you to call it something, call it that. Otherwise, you can use toString. You can use display. You can use any description you want. We generally don't really get that fussy about what you call it. As you can see, there's no indication of what you should call it. It just looks at the actual output when you store it to a grid. So we don't care what you call it when you call the function, unless we tell you what to call it. There's a big difference. If we tell you what to call it, like we do with the evaluate attendance and the constructors, then you need to make sure that you call it that specific name. Otherwise, it's not going to be found, or it's going to be more difficult to find it. You will lose some marks, but not all the marks. You'll most likely just lose a mark for the naming convention. Right. Now coming to what is actually important for tonight, what you guys indicated that you want to see, is the form code where we're going to handle the actual reading and writing from a structure or a random access file. So let's go through this. We're going to go through this slowly. Once we've gone through this, we can delete all of this, or all the file related code, and do it ourselves. Just so that you guys can kind of see what's going on, but also to kind of see if you have to do it off by heart, how will you do it? Are you comfortable with it, or are you not comfortable with it? Right. So first things first, the option statements, you will be deducted, or the marks will be deducted if you don't include them. That's in every single one of your classes. You've got your system.io. Now, because we're just using random access files, we don't have to include the binary formatter because the .io classes or the binary writer that we're going to be using is contained inside the .io. ToString doesn't need return. ToString generally is a string output. That's why it's called ToString. So if we can just go back to that, I'll show you ToString, string output. The idea here is it's just a string output. And that environmental.new line, you see this FBCRLF, that is the code constant for a new line. So when you call environment.newline, that is technically what you're calling. Okay, line 23 in which class? In class, you need to tell me which class now because we were jumping around a bit. So if you're going to call out a line, please make sure you include the class as well. Okay, the ToString 1, class 1. Are you referring to class exam? The ifm.exam or the ifm here is a DLL that we're including. So this is a DLL. So in this question paper, DLLs, back then we did DLLs early in the semester. So you'll see here it says, locate the file. This is a DLL file. Use it to instantiate the ifm exam object. So your object was inside this DLL. It's already there. That's why I'm just gonna like breeze over it because it's not something you have to be too concerned about, this ifm structure. Just see if I can open this up here. So if you look at this, your ifm class is this location of file string. And then you've got a location. So file creator, ifm exam. If you look at the, I lost it now. If you look at the actual class, it's a subroutine locate as string. So you give it the location, and it will create the function for you. Where's the full DLL though? Yeah. No, you won't get a DLL. We won't give you a DLL. I think this is one of the reasons why we didn't upload this particular paper for you, because that first part will most likely just confuse you all. Just remember, this file, ifm file, if you read the question carefully, it says, so locate it, then use it to instantiate an ifm object that will create the random access file is capable of storing 15 of the following records for you. So that, calling that specific function will instantiate the ifm object that will create the random access file that's capable of storing the object. So this entire section is about creating that random access file. I think we missed the right return on function ToString. Mean up here. So you see the name of the function itself. So if you call a variable the name of the variable and assign it a value, then that represents a return. Now it's not the best coding coding. It's not the best best practice. Sorry, that's the term I'm looking for. It's not best practice. So that's why we enforce you to use the term return to return a instance variable, because you'll see that this is not declared. It is essentially toString because your output is a string, so it can see this as a sort of a temporary declaration, and then the entire string output is this. So that just sees it as that is the return. That toString is equal to this, and it just indicates that that is the return. All right. But you need to use return. We've shown you the proper code usage, so you need to use the proper code usage. Can't use any other shortcuts. And underscore, let's just see. Now I closed it. So you've got this is and just indicates that it's including this part as well. So that just refers to and, it refers to the fact that it's going to accept the next line. So instead of saying this is separate a separate code, it just refers to the fact that the next line is included into this line. Just makes it easier to read if you format it like that. The way we've shown you how to do that is have the variable name ampersand, not ampersand, and equals to, and then the string, which just appends it to the actual string, whereas this is basically everything on one line, essentially, with the declaration or the new line constructs at the relevant points. So it's just so it doesn't drag on to the right. Yes. So that it fits into a nice block and you don't have to scroll to see the entire line. Once again, you can use it if you want to, but like I said, what we taught you is building up your variable line by line. So using your ampersand, your append to your string to basically simulate it as well. You can essentially see this as that is when we say toString equals or and equals and then the next line. So this is just one line essentially. All of this is just one line. Just formatted so that you can read it easily. It's meant for the human, not for the machine. Right. So if you go through this, we've got file creator as IFM exam. So this DLL is going to create that random access file for us, the initial file. Then we've got our private construct of file location as string, and then we have the file name itself. Now remember, there is a naming convention. In this case, this would be your student number.ifm. And then that will be a constant, so you know that the file name is set and nothing can go wrong there. After we have set our file name, is that good enough for you? Let's just maybe hide these as well. So after we have set our file name, we open up or we create our file stream, and we can create our binary reader as well. I don't mind zooming in. It means it's less pixelation on your side when you zoom in, so it might just help some of you. Then we've got our structure that we have to define, which is our ID as an integer, our fixed string 25, our fixed string 15 for subject and lecturer, our integer for number of students, and our integer for number of students who wrote. Now, one thing I want to point out to you, this essentially is for you, the developer. So do you understand that this is limited to 25 characters? One, it helps you to determine the right size that you need to take in consideration. And two, if you need to limit the actual input method, like the input box or the text file, to a certain number of characters, that you know what the limitation or the string limitation is. If you have some validation, you'll apply it there as well. If you forget to include this, it is not a train smash, because keep in mind that this doesn't actually alter the structure of your string. It's more of a reference for you to remember that subject name is limited to 25 characters, but if you put more than 25 characters into the string, the system's not going to do anything about it. So just keep that in mind. You can use that. We would prefer if you use that, but you could potentially also just comment it in. Right. We'll get to the size in a moment. Now, once we have our record structure, this is now our object. So our object is set for our information to be stored to our file. Now, if you want, and I would recommend this, if you know this is the object you're going to be storing, at the top, add a comment for yourself that says your record size. Do that. Or add a variable for yourself that will say private const rec size as int integer, and then set the file size so that you know that your record structure file is set. Now let's look at this. I'm going to open up the calculator. Let's look at this in terms of how much space we need to save. How many bytes does an integer use? 4. How many bytes will this 25 character string use? 50. How many bytes will this 15 character string use? 30. How many bytes will this number of students use? 4. And how many bytes will this number people who wrote use? Yes, 4. Now, for those that are confused about the byte sizes, we will release, I'm not going to call it a cheat sheet, but we'll release like a info page that has the different byte sizes of the common file structures that you'll most likely, or the common data structures that you'll most likely be using. So that you all have it on one page. Yes, a double is 8 bytes. So 4 bytes for your integer value and 4 bytes for your decimal value, essentially, your post comma, post point value, essentially. So what is a byte size for a Boolean in VB? Actually need to check on that. It's supposed, according to me, it's supposed to be one bit. Because it represents a 0 or a 1. I'll just have to double check on that. I'm not 100% right now, and I don't want to give you the wrong value. So let's maybe just quickly look that up. VB Boolean byte size. Okay, so let's see. Good question. We might just have to test it out. So it depends on implementing platform. Okay, so we'll test it out. We'll go and calculate that in a moment. We'll do a small test program to figure it out, and then I'll tell you exactly on Thursday. Just don't want to waste too much time doing that right now. Please just remind me in the chat on Thursday if I've not done that to do that. But you don't have to worry about it. We're not going to ask you a Boolean for your Friday test, essentially. But it is important to add it to that information sheet for you to understand. Now, keep in mind, as the official Microsoft documentation said, it depends on the platform you're using. So it also depends on the language you'll be using, how that language specifically represents it. Let's see if we go private test as Boolean. Let's look at the structure. Represents a Boolean true or false value. Come on, open it up for me. So Boolean. To me, it seems like it's going to be actually can't see here. But we'll look at it. I'll have a look at it, so I won't leave you guys in the dark there. If memory serves right, it should be either 1 bit or 1 byte. But I'll confirm that for you. I'm leaning towards 1 byte, but like I said, I'll have to confirm that for you. Right. So we have now, where were we? Did I change something? Yeah, I'm in the wrong code set here. So we have determined that it's 92 bytes. We write it into this constant file so that we can always be aware of what that byte size is going to be. It's a good thing to keep that in mind. All right. Now, we have our load function. So when the application itself loads, it's going to do a file creator, which comes from our DLL. It's simply an object of the DLL. So file creator as IFM exam. I'm going to briefly brush over that because we're not going to give you a DLL, but we've got file equals new file, and then we just put the file location in there. That's the file location. That is now your local file to create that random access file. We've got file creator equal nothing. So we just make it null. We label everything, and then we load our file. Now, remember, you have to close the file itself. Essentially, here, it will close the file for us. We're just making sure that this file creator is essentially handled by just deallocating it from memory. Once again, it's something we expect you to do right now. So every string in structure must have fixed string. Now, this is just a reference to the developer. It's a nice to have. It's a good to have for the developer, but it is simply just a reference. It's not code-wise going to change the structure itself. It's not going to limit this subject name to 25 characters. You can still exceed that, as we have shown you, I think it was last week, Tuesday or the week before that. So can you show the load file? What do you mean the load file? Okay, so let's just go through this. We're going to go through this, and when we get back to specific points. All right. Now, this part of the code is simply just to create that DLL, which is given to you. That was given to you. Do the garbage collection, and then after that, we have our labels that we place and our load file, which is going to load up the file for us. We've got our hash function here. Our hash function here is simply just modding our ID, dividing it by 13, multiplying it by 92. So it's a prime divider here. So we've got the ID, modding it by 92, modding it by 13 because there's 13 spots in this file. Keep in mind that that value was given to you. Sorry, 15 spots in the file. And then 13 is the highest prime number to 15, yes. And then we find a value between 0 and 12, essentially, and we multiply that by 92, which gives us our specific location of where the byte will start. So that's the hash function. Very simple, easy to use. What if you chose 17 as the prime number? So the problem with 17 as the prime number there is you're only going to be storing 15 values. So 17 exceeds the max of 15. So you can have a situation where you have more, you have a spot that doesn't fit into the file. So what it does, it takes the number formula, but then if there's a collision, the collision is handled separately. So with those empty spots you'll have, because you'll receive a spot between 0 and 12, which means 13 and 14 will still remain open. And then those will be based on collision situations, which will be handled in code. So the number given was 15. Sorry, I misspoke there. The number given is 15. So the file is capable of storing 15 of the following records. And 13 is our highest prime to 15. All right. So if the amount given was 13, then you would have used 13 as your prime number. So you use the prime number that's less or equal to your value, but not more. It can be equal to the value. So if you have 13 spots, you can use the prime number 13. But if you have 14 spots, if you have 12 spots, you would use the prime number 11. So use a prime number that is equal to or less than the amount of spots you have available. Yes, that's how we discussed it. Now, it's not a big train smash. If you, let's say there's 13 spots and you use the prime 11, you won't penalize it that badly. You'll probably lose maybe 1 mark if you lose any marks at all. It really depends on how bad the mistake is. If it's absolutely wrong, then obviously it will be marked wrong. But if it's like a very minor mistake, it doesn't actually influence the program at all, then it will be assessed based on the face value of that specific error itself. Now, if it's just a prime number issue, then you'll probably just lose, you'll either lose a mark or you won't lose any marks at all. All right. So is there a 50-50 chance that the semester test will either be sequential or random? Yes. Aren't we supposed to mod by 47 in this case? Because remember that P is the largest prime number less than given value. Sigoyo, I think you missed something maybe somewhere. If you read the question carefully, it says, where is it? So create the random access file that is capable of storing 15 of the following records for you. So 15 is the maximum number of records we're going to be storing in this file. So that's why we mod by 13. No. I think you might have misinterpreted. I said 50-50 based on Lunchman. Sorry if I'm mispronouncing your surname. He's asking whether there's a 50-50 chance between sequential and random access files. Sorry if I misspoke somewhere there. I maybe just twisted my words slightly. But for this specific semester test example, you have a maximum of 15, or your file has a maximum of 15 records that it can store into that file, which means your prime value will be 13. Now, we have given you a link to the prime numbers. We'll probably add it to the I don't want to call it a cheat sheet, but like the info page. We'll probably list the first few prime numbers as well, so that you just can have it quickly on hand if needed. Random access files are easy once you get used to it. Well, I guess that is the thing, once you get used to it. Right. Then, reading a record. So remember, once we have established our record and we've added the information, easy is relative. I know easy is relative. So once we have established, as it says, so we'll copy over that data file that was given to us with our test data. You'll be required to provide the location of your file. This will create the file and save the necessary records into the file for you. So this file will be created. Should you not be able to do this, copy the file ssa-data.ifm into your local folder and rename it to the appropriate file name. So if that function didn't work, then you can just copy the file that was provided with the test data. But essentially, after this function has been executed, where is this? After this function that was given to you was executed, the file that was created will also be populated with information. If not, you just copy over that file that they gave you that has the test data in there. And once the test data is in there, then you would just populate the grid with that information. So let's do this in order. So load file. This would then load the file that was just created. So file stream, new file stream, or new file stream, location of your file, opening the file and reading from the file. Remember, now we've created that file. We've put everything, or essentially that DLL put everything or the data in that file for you. If that didn't work, then you copied that file over and renamed it. And now we just want to display the information from the file. Remember, it's created it, and now you want to display that information to the grid. So you've got your file writer and your binary file that you're going to create that just reads from your file stream. You've got the 4R as integer equals 0 to 14 because we've got 15 objects in our record structure, which means we've got 0 to 14 for the 15 spots. We've got our file stream.seek, so we want to make sure that we output everything inside this file, so that is from position 0 to position 14. Multiply that by our record size. Now, because we have this constant, I recommend that you use a constant for this. Use that constant instead of writing the actual value here. It just makes it easier for you to kind of get used to the fact that that is the record size. Right. Then you've got file seek origin. That just says where am I beginning this file search from, and that's from the beginning. Then you've got a temporary record file that you're setting up off of exam info. So that is the structure we have up here that we created. And we're just reading everything into that structure. So what we do is we read the ID. So we read the integer from the ID. We handle the situation of ID equals to 0, and then we just show that it is empty. We populate the grid with empty information. So just placing our results for our columns, our rows, and then the text to just indicate that if we encounter a 0, if that ID is a 0, it represents that there is nothing there, as it is defined in our question paper. It says here, let's just get that exact spot quickly. Oh, here it is. The value is 0 if the record is empty. All right. The information you need to be aware of, because that means you have to handle it. So what we're essentially doing here is we're going through the entire file and just outputting or dumping the entire file into our grid. So if it is not 0, then we can read in the information. So we read in the information from our stream, from our binary reader, into our temporary storage, which is our temporary structure we created, put it into our temporary structure, and then place our temporary structure into our results, which places it in the grid for us. Once this for loop is done, then we can close the file stream and close the binary reader, sorry. Then we've got our place labels. I don't believe I have to explain this to you. You've been placing labels since the first semester. You have to place your results, which is puts the information inside the property methods for you. You've got the exam variable declaration. Now, I prefer putting all my variable declarations at the top. You can break it up like this if you want to, and I have seen some of you do it in your code. It's easier if you read your global variables from the top. And this is just simply taking information from the user, putting it inside the classes that you created, appending and then displaying that information, and then obviously over here you're just taking a min function to your classes that once again you've already populated. Okay, so what do we want to handle? Do you want us to code this out from scratch? So you guys tell me what to code out so that we can see where you understand this and where you don't understand this. All right. So what I'm going to do is we're not going to be concerned about the output right now. We're purely going to be concerned about retrieving the information. Are you guys okay with that? Because then we can probably go through it once or twice. Well, twice. I mean twice. All right. So let's remove all of this. This is the load file. This is where we're going to read from the file. Because I think that's where the major concern is from, reading from the file itself. Now, we're going to read from this file. Everything's been loaded. Everything is there. We just simply want to read from this file. What do we need to do? I'm assuming you're the only one that can't hear my audio right now because everybody else just answered a question for me. Are you back? Okay. Restart the stream. I'm recording. I can't restart it, unfortunately. I think Blackboard just timed out for a second there. It's probably just the overall board itself. All right. All right. So let's load this file. Now we're going to ignore this code, this read record, which is going to read a record from start to end for us. We're going to create this essentially. So let's read from this file. How are we going to read from this file? Now remember, the purpose of this is open file stream, read from the file, pull the file itself out, find the information, and then close this file stream for the entire file. That's the purpose of what this is. If load where we create the random, okay, so the random access file was created for us by the file creator. We can maybe just quickly go over that as well in a moment. So let's look at loading this file. Let's pull everything from this file and then put it into a temporary record for us. We can even put it in an array of temporary records if you want to. Now, when we're working with a file, what's the first thing we want to do? When we've got the file exists. We want to read from this file. Loading and saving is it's very close to one another. We can look at an example of saving it after this, but we're now going to look at reading. So reading from the file is more difficult than writing to a file. The binary writer doesn't actually ask you for a data type, it just writes it because the data type is given. Reading, you have to say what the data type is. All right, so when we read from this file, I've got my file. The file is in the local folder, in the folder that has been defined up here. File location. We've got our record size, which we've already determined is 92 bytes. We have our hash function, which indicates the position of where this file starts from. So how are we going to start this? What is the first thing we need to do? FS and BR. So we need to create the file stream. Remember, the file stream is the temporary. It's basically taking that file and loading it into memory so that your application can use it. Binary writer is so that we can read, or the binary reader in this case, so that we can read from this file. So we have our file stream, and we're going to create a new file stream. And this is for the file name or directory that we've given it. So this is the file location. This file location is that naming convention that we provide you. We'll tell you exactly what to call it as indicated over here. Over here. So we tell you exactly what to call it and the extension. So keep that in mind. So in this case, if you don't want to set a local file up, it would be your student number .ifm. Means you have to write it every single time. Or you can have that constant, which is just your file location. Then we've got our file mode. File access. And what do we want to do with this file? Sorry, our file mode first. What do we want to do with this file? If you're reading from this file, what do we want to do? Do we want to create? Do we want to open or create, append, create new? Okay, we want to open. Okay. Remember, if you're reading from this file, you're going to open the file. If you're going to put things into the file, if the file does not exist, then we're going to create the file. If the file does exist, we're going to open the file. Always remember that. If you're unsure, think about it this way. Create, brand new. If you had something in there, it's gone. Open is if you have something there, you can open up, no issues. But you can't open something that does not exist. And if you try and create something that exists, it's going to delete everything inside the file. Just something to remember when creating a file. Right, you've got file mode open. Then you've got the file access. Now, in this case, we've already said we want to read from the file, so you know it's going to be read. Is there a reason why we can't use read and write? You can tell me, is there a reason why we can't use read and write here? I want you to think about it for a moment. For what reason will we use read instead of read and write? To be loading. Okay, read write is only if you're going to read and write at the same time. That's if you have information coming out and information going in. Correct. You're not writing to the file, so there's no need for us to access it as read write. The other reason is the moment you start writing to a file, it blocks all other applications from accessing that file. Reading from the file doesn't lock the file down. Opening it in the wrong file access method or option means that you can potentially lock some other application out of the file. Right. We've got our binary reader, which is just simply going to be a binary reader. No issues. Okay. Parameters, file stream. Yes, parameters, file stream. So no issues there. All good. Read. Oh, right, sorry, I keep on saying read. Reader. So what are we reading? We're reading the file stream. Right. Now we've got the file stream open. What's the next thing you need to think about? I've opened the file stream. What is important to remember once I've opened this file stream? Doing it step by step. Not seek. Logically, seek is the next approach, yes. But if I open this file, what needs to happen when I'm done with this file? I need to close this file. Do yourself a favor and go and close it from the get-go. Don't wait until the end. Go and close it from the get-go. Because then you know, there's the beginning of my function, there's the end of my function. There's no issues. Can't close be on top. Well, how do you mean close be on top? If you open up the file, then you can close the file. I don't understand what you mean, can it be on top? Did you just accidentally think of something else? You kind of need to open it before you can close it. Or are you thinking, in case the file has been opened somewhere else, you just want to make sure that it's closed before you actually use the stream? Yes, yes. I just mean type it so that you know it's already been done, and then the space in between is where you're going to write your code, or the importance of what you're going to do this file with. So it's more of a case of when you open the stream, make sure you have the closed stream code there, but then you're going to code in between them. Because what you do in between, you know that when you're done with it, it will close. I've done it a lot, and it happens especially in a test. You write your code open, you do your program, you test it, it works perfectly, you save, you submit, no issues. And then when the mock gets back, like, why did I lose these marks? It's never closed. But when you tested it, it worked because you only tested once. You only run it once in the scenario where it's going to open, so you never actually see it crash on the fact that it's going to crash because of the close. No arguments there. It's something you can code out for fun as well, but it is something you need to consider. The thing is, it can be passed as an object, so it's not always necessary that you want to close it in this instance. Something to be aware of as well. So eventually it must close, and the garbage collector will, if you close the application, the stream itself will close as well. So if you close the application, try it again, it will still work, because it won't see it as the stream is still open, because the garbage collector will close it for you. Don't try it on Friday. Oh man, you are brave. All right, so we've opened our file stream. We added the close code to the bottom, so we know we close it. Now, the next logical step we want to do. We have the file stream. The file stream is now in memory. No, so we flush when we write to a file stream, just to make sure that we push everything outside of the out of the pipe and make sure it's into the file. When we read, we don't need to flush because we're pulling it into the pile, into the pipe, if I can suggest it like that. So when we read, we don't flush. When we write, we do flush because we want to make sure the pipe is clear. We want to make sure everything we put into that pipe is into the file. All right. Now, open file stream, we have it in memory. What do we do next? Seek. All right. So you're saying seek. What am I seeking? So yes, in this case, remember, we in this paper, this data was provided to you and was said that once you loaded the file, created the file structure, or executed the DLL that created the file for you, and then also populated that file with information for you. Okay, file possession. There's what I'm getting to. Now, see, this is one thing you'll notice. Look at your code logically. The next logical approach is I need to seek. What do I need to seek? I need to seek the location. So I'm just going to write location here. Location. What is the location? In this case, our location should have been identified by our loop. So we first need to create our loop. So let's go loop. Let's actually call it location. Location. Well, you can call it key. Let's maybe call it key. Integer. We start from position 0 to position 13. Keep in mind, it's position 13 because 13 is our prime. No. Is it 13? What do you guys think? You say 15, you say 14. You say 12. 15 minus 1 equals 14. Okay. Why 14? Because we're using the prime number 13, but why do we want to use 14? Starting at 0, correct, but why 14 specifically? What comes you to the conclusion that it needs to be 14? Come on, give me the key phrase. I know you guys know the answer. I want you to think about it because it's in the back of your mind. But on Friday, I want it to be really, you need to be conscious of this question. Yes, 15 record positions. In the question paper, it says that there are 15 record, or the file stores 15 record positions. Now, because VB starts at 0, we have 0 to 14, which gives us 15 positions. All right. I know you guys know this, and I know it might seem a bit trivial to cover it like that. Let's just see what are we doing here. It's complaining about the next. So let's just do our next key over here. Sorry about that. All right. So it needs to be automatic. I know you guys are aware of it now. But when you're in a test, I want you to think about these questions because these questions will help you type out the code maybe a bit slower, but with less mistakes. If you do your code fast and you make mistakes, you tend to not go back if it runs and it executes perfectly. So I want you to question every single line you do, not to the extent that we're questioning it now, but to the extent that you are comfortable with, I have a reason why I'm using this value. Justify it for yourself, validate it for yourself. I'm answering a question, I'm using the values given to me for this question. So we can't start at 1 and end at 15. No. Because remember, our hash function returns based on the value given. If I take 1 multiplied by our record size, which is 92, what is my value going to be? $92, which means if I start at 1 in my file, I'm going to start at byte 92. So I'm skipping 92 bytes before I actually start reading the information from the file. If I use 0, I start at byte 0 because 0 multiplied by 92 is 0. So I guarantee that I start at byte 0 in my file. So this is now not a consideration for the why we use 0 in an array anymore. It's for the fact that we want to start from the very beginning of the file, which is byte 0. And then the first 92 bytes is one record, and then the next 92 bytes is the next record. But if we start with 1, we're going to start on byte 92, wasting 92 bytes worth of space. Right. We've got our key. Now keep in mind that we do have our hash function that was created. So it's just giving the hash function the key, that mods it by 13, multiplies it by 92, so we get our record structure out. So essentially, instead of having to say key times 92, I can use my hash function over here, the hash position, and just simply give it the key and it will give me the position itself. Now, if you don't use the hash function and you decide to type it out, so instead of saying hash, you decide to go key times 92, it's not wrong. It does the same thing. In this case, when you're searching for something, then it's going to be a different result. Now, keep in mind, because the key is a value between 0 and 13, it works with the hash function. But also keep in mind, it's not the intended use of the hash function. The intended use of the hash function is for you to give it a key, which is the is the ID. I want to say student number, but it's the ID. Isn't that? I'm assuming it's the ID. And the ID, it's hashed, and then gives you a value between 0 and 12, and that is multiplied by 92, so that you know where to uniquely find it. Right. So in this case, even though it's not meant to work with the hash function here, it can work with the hash function here. But we're going to use the record file that we have. Sorry, it was record size that we created at the top, which represents 92 bytes. So it's 0 to 14 multiplied by the record size so that we find the specific block we want to use. And then we have our file origin. File origin file. If my mind is a mess today. File origin. Okay, guys, give me the right code here. My mind is playing heavy tricks on me right now. Origin. Seek origin. Thank you. Seek origin. Let's begin. Because we want to begin from the beginning. So all this indicates is the fact that we want to seek from the beginning of our file, and not in the current position and not at the end. So there's three options here. You've got begin, you've got, I think it's current or to position, and then you've got end. So you've got begin, current, and end. And we will most likely always use begin for the scenario of what you're doing. You're now reading this file stream. Anything else we need to add here? Is this all good? What does this specific line do now? Yes, it gives us a location. This gives us a location. It tells us begin at this point. That is what that line tells us. It tells us begin at that point. Now, we can do our temporary structure, which is our record structure. As what was the name of this record structure? Exam IFM. Come on, don't be so mean to us. Exam info. Then we can start reading. So we've got our read record. Read record.id. Believe it or not, I'm actually watching the stream while typing this. I'm not watching the actual stream I'm typing on. Stupid. How do I read this? Just tell me. Binary reader dot and what follows, and why. We are going to go slightly over time with this one. I do apologize for that, but I want you guys to really think about every single line when you're reading. Okay, why are we reading int 32? Why int 32? What's the purpose of reading int 32? Byte, okay, expand that explanation for me. I know you have the right answer there. Just explain it. Why int 32? Read int 32. Why specifically read int 32? What does that represent? 4 bytes. All right, for those that are not aware, int 32 represents the number of bits in that structure. So int 32 represents that there are 32 bits in that int, which is equal to 4 bytes. And because we're using an integer, it just states that that actual int structure we're using is integer. It's not the long, which is 64, and it's not the short, which is int 16. So int 32 is the general integer bit size. So it identifies it by the bit size, so int 32. It's a 4-byte signed integer from the, okay, but now you're just Googling things. Yeah, I thought that was the Larry Tesler in there. Right. Now, reading that first value in, what is important here? What is the next step to do? Order. Order is important. So let's maybe go through this. Let's read everything in quickly. So I'm gonna quickly list them out. So we've got a string, integer, integer. So I want you guys to just quickly indicate what the read will be. Let's type this. Say subject name, lecturer, number of students, right. The subject lecturer. Yeah. Number of students, and then number of. Okay. Oh, come on, guys! I told you to quickly do this. We've got br read, and we're reading a string here. We're reading a string here. Read int 32, and then read int 32. Okay. So we've now read that information into the subject. Now, here's my question. If the information is blank, what's going to happen? Can we have an if statement in this loop that will close the file stream? Well, remember, we look through the entire file here. So in this case, we're going from the beginning to the end of the file and then returning all of the information. Otherwise, we would just leave it. Right. Okay. I want you guys to really think about this now. What happens if this ID is 0? What does that mean? Because remember, we're reading from this file now, and it says here that if this file, if this ID is 0, the record is empty, which means there's nothing there. What's going to happen to these 4 values if there's nothing there? You say we're returning blank record, I think. But in this case, we're just going to write the ID and most likely nothing else. We have to assume the worst case, and the worst case is that blank information was not written for these. So what do we need to do? Because if it is blank information, what will happen if it's nothing, not blank information, if it's nothing? What's going to happen if I try and read nothing and put that into a string or an integer? Null exception. So null is not the same as blank record in this case, because remember, a blank record will be a bunch of empty spaces. An integer, a null integer, is represented by a 0, which in this case, if we read in a value here, number of students, it's not 0, it's nothing, which is the wrong information. It's supposed to be empty. So what should I be doing here? You guys tell me, what should we be doing here before we start reading? And why? Specifically why? I want you to think about this. It's one of the beauties of using a random access file. Validate the identifier, yes. Why do we want to validate the identifier? Because if the identifier is 0, it means that there's nothing else there. So if we test this, if we quickly test it, if we say if the record that we just read, if this record.id equals 0, what happened then? Not a try catch. Remember, it's in the question paper. It said you may assume, you do not have to implement any exception handling. What do we do if it is 0? Empty string. Empty string. We can have nothing here. Nothing there. Because it's nothing, it's empty. If it's not empty, then you can read the rest of the file. So make the rest of the record empty because it's empty. And if it's not a 0, if that ID is not a 0, you can read the rest of the structure. Now, why will make that record empty instead of reading from it? What significant difference does this do? Why am I making it empty? Why am I manually allocating empty information to this record instead of reading nothing into this record? Apostle, you're very close to the correct answer there. I think you're just phrasing it incorrectly there. So make sure that all file positions are used, not specifically. I think you're referring to the correct one, and you can correct me if this is what your train of thought was after I mention it, because the position will be filled with blanks. Okay. So you're reading every position. in this file from position 0 to position 14. You're checking the IDs because the ID will be a 0 if the rest of the information is empty. If the information is empty, I don't need to read the rest of that record because I know there's nothing there. Now, because I am outputting this information to the string or to my front end, I need some information at least inside my record structure, even if it is nothing. Because I can still display an empty string, but I can display a null if I read it from the file and I don't address the null value itself. Because it will still tell me null. It might crash on me, it might not crash on me. So it's better to handle it and check for those conditions, check for that situation. Student number and number of students and number of students that are writing, same situation. But because the ID is null, I don't have to try and read the rest of that specific record. So I finish the loop, I'm manually putting in the information, and then the next if statement, the next for loop, pushes me to the next record block where there might be information again. So one, you don't waste time in trying to read nothing. You know it's nothing, you just simply allocate it. Two, you kind of stop a error from occurring. Because if you know what the outcomes will be of the fact that there is nothing there, why waste the resources or the time to read it if you know what it is? Now, if it's blank, depending on how you display the information, you can either handle the display right there in the if statement, instead of having the record set to empty spaces, or you can simply just fill the record with empty spaces, and then after your if statement, like over here, once you know you've read everything from the file, or set that specific record with information, and then do your display here. So you can either do your display over here if you want to handle everything, or you can do your display after the read-in file here and after the file there. Personally, I would say set the record information there and then display it over here, because then you don't have to duplicate code. Right. Right, then we've got a question here. So we don't need to use lset. No. Lset is when we want to fill the record with empty information. So lset is giving me that block. That's when we write blank information to the record structure. Right. When do we display in files? So this is reading from the file, and then your display, I keep on trying to click on the stream, and then your display will be over here. So this will be where you place your results. Give me the, let's see, what do they want? Is it column first in this one? So you give me the row first, the column, and then give the actual information you want to display. In this case, it will be your, let's say your ID. So your row will most likely be the specific information you're looking at. So this will be, what do we call it, key. Your column, if it's your ID, will probably be the first column and then your ID. And you've got P. 4 records. Is it 5 records? 5 records. You've got 2, 3, 4, 5. So you've got your ID, your subject name, your lecturer, your number of students, and then your number of writing. It's giving an error because I'm not using the actual record in front. Let me just maybe add that, because someone's going to complain about that most likely. already know someone's going to complain about it, so let's just add it and say it is there. Right. So it's simply just going to give you the information, then write it. It's just and these last two, or these three, are giving issues because it needs to be strings. Just add that as well. Just avoid all questions. Just add that as well. Right. So that needs to be a 5. You're correct. So it is just simply ID, subject name, lecturer name, number of students, and then writing. So once I've read it from the file, I can output it to my grid. Then I can go to my next item or my next line in the file. So this will now be swapped over to 1, and then I read that position, 2, 3, all the way to position 14. So we ensure that every single item in this file is read. It's different from when we're giving the ID itself. So if we're looking for a specific value, we only want to retrieve a specific value. Instead of doing a for loop, you'll do all of this without a for loop. You'll just simply give it the ID, hash the ID to find the location, and then read that information. And then, output that specific information itself. But the idea, the concept is still the same. It's just not the for loop. But over here, you're trying to output the entire file and not just one specific item. How would you pass the value into a class? All right. So you have all the information here. So in our class, let's just go to our class. We've got this constructor. The constructor takes an ID, a subject name, a lecturer name, a number of students, and then the number writing. So we can just simply, if we want to, let's just see, that's called C class. So if we go dim, let's call it temp. We'll most likely put this into an array, but we'll just use a temporary variable for the moment. So C exam, and then temp equals new C exam. Just see what it's called. New C exam. And then we can just simply pass the record ID the record name for the subject name, the lecturer name, the students, or number of students, the number of students writing. That should stop. Oh, this is a inherit, so it needs to be one of the derived classes. All right, so let's take we'll just use any one of them. So let's use C theory. Say this was a theory exam, and then we would just need to add actual, make sure. Nope, we don't need to add the exam link. So we've got our information. We put that into C theory. Why is it complaining? What am I missing? Oh, number of pages. Yeah, I'm missing that. So then we just have our number of pages. So at this point, I'm just going to say 20 to satisfy the actual agreement here. But that is now the information, and we're passing that information into a class. In this case, I've got the class as C exam, but the C exam is a must inherit. So it's C theory or C practical that has to be used. It's down here is the where you would populate all of that information, but you can pull it directly from the file itself. So once you've read all the information, so instead of displaying the information, you want to put it into a class, you can just simply use a temporary holder, put it inside the temporary holder, and then take this item and put it inside an array if you want to. What would happen if you dim read record as object? How do you mean? I mean over here, if we do this as object, then it's just an object. Remember, read record is the structure of exam info. Object is just an object. Object is in itself a data type. It's kind of like the base or the parent or the root data type for all data types, because everything is associated with an object, and an object-oriented principal language, which VB is what. So everything is based on an object definition, but it's not an exam info. Exam info is an object, but an object is not an exam info. But just keep in mind, it's not directly derived from object, so it won't allow you to use it as use derived classes that we code ourselves, which has a direct correlation between the two. Object in itself doesn't have a direct correlation, a direct link, to all the other classes that we use. It's only at a fundamental level. Supports all classes in the VB.NET class hierarchy and provide low-level service to derived classes. But it's not that every class is an object. Not every object can basically be substituted for anything else. I'm assuming that entire sentence makes sense. Okay, you say it makes sense. I'm happy for that. In my mind, if I was a student, I would be confused right now. So I spoke myself into a circle here, but the idea here is everything is derived from an object. Because the object itself is of a low-level service, it doesn't mean you can use every other data type as if it is in its base form. All right. This was an enormous paper. No, it's just basically it's the explanation that we did that took so long. Remember, you've got 3 hours to do this. We spent about an hour and a half on this explanation. If you had to type this out, code this out, you'd probably be about halfway right now. If I would have to guess, if I had to write this paper, let's see, you've got your interface there. You've got your 2 papers, which is not that much code. You've got your theory, which is the majority of your. So it's more definition. There's not really a lot of code there. Here you've got functions and formulas, but remember, these are given to you. If you look at the table, all of those things are given to you. You're just basically translating it into code. And then in the VB code, it's all based on. Let me just fix this because this is getting too annoying. Exam info. So it's all input. This is all input boxes. So you've got read them, input boxes. You've got your choice. Once again, you're testing a choice. You've got your input boxes, input boxes, input boxes. It's just all input for your classes. And then your display, which outputs something for you. And over here, based on your input, you're just going to read or search for the minimum value. So it might look like a lot, but once you actually start with this application, remember you start with a design first. Once you design it out, you'll realize, okay, it's or just a matter of logically approaching it first. Sequential files will probably seem easier to you. Yeah. In this case, all of this code is, you would have to write all of this code yourself. But you've got 3 hours to do it. That's why I say don't stress about it too much. Sit, think about it, do your design, and then just logically write it out. If I had to write all of this code, it will probably take me about, I would say about 30 minutes to an hour. If I debug, an hour. If I don't debug, it will take me about 30 minutes. Roughly. Let's see. Maybe a little more than 30 minutes. If I don't have to refer back to the paper, then I would say 30 minutes. You are given, so here's my suggestion. Generally, the first 10 minutes you will not, if you had to be on campus, the first 10 minutes you would not have been allowed to even touch the machines. You are forced to do the design for the first, I think it's 10 minutes. Ms. Gottrell can correct me if it was more. For the first 10 minutes, you were not allowed to touch the machine. You were only allowed to do design. Because these applications are, I would say, slightly larger than we used to, but the thing is, you're used to having about a week to do these practicals. Now you've got 3 hours. So design is going to be crucial. It's going to identify your inputs, your outputs, and what the algorithms are going to be and what your interface is going to look like. Though those design concepts, just breaking them down into those small pieces, it's going to save you so much time instead of just jumping into it, coding it from the get-go. I can promise you, if you just do a design before you start coding this, you'll probably spend less time coding it than what you would have without a design. Because you start thinking about what you're going to do in code while designing it. So take the time to do your design. 10 minutes, I would say 20 minutes maximum. If you start spending more than 20 minutes on your design, then you start wasting your time. I would say you need to spend about 10, 15 minutes maximum on the design itself. No more than that. You don't need more than that. But it gives you time to go through the paper, make sure you understand it, make sure you read the things carefully, double check it for yourself, and then you can start coding after you've done that. Because then you shouldn't really have an issue. It's just basically hashing out what you need to do. Right. I find that doing a rough design helps a lot before the time constraints make me doubt it because I have to rewrite it out neatly after. Any advice? A rough design is good. Remember, your design doesn't have to be perfect. Design is supposed to be a suggestion of what to expect. We don't expect you to go to design and then follow your design exactly as you thought you would have. No one in the world can do a full program. I'm talking about real scale programs now. It comes with experience. No one in the world is going to do a full scale program from the start with one design and say, this is what we're going to do. It's never going to change. I can promise you 99.9% of the time, something in your project is going to change. And obviously, we're realistic. We look at it like that. If you do your design first and you start coding it, you might realize, okay, I might need another variable here. And just add it. You're not going to go, okay, you have this variable, this variable, this variable, it's not going to work. We're going to look at your design and we're going to be, okay, do you have the minimum required information in order to do this application? If yes, then there's your. If you want to use additional variables, that's up to you. But as long as your design is a logical thought process of how you're going to apply how you're going to implement this program or develop this program, and it fulfills the requirements of what we want from the design. So submit your rough. Easy, short answer is submit your rough. But make sure your rough outlines everything that is required though. So we still need to be able to read it. All right. From line 119, is there any case where you must do it all in a file? User input in a file. In this case, I don't think this was saved to a file. Let's quickly check. No, this wasn't saved to a file. I don't think the question paper actually wanted you to save to a file. Because we created the file at the top. We have a single node show determine the lowest. Okay. So in this case, it didn't want us to store this information to a file. Where do you store data for the record structures? Can you just maybe expand on that a little bit more? Right. So in this case, the file structure itself was created for you with the DLL. Because of how much time there is available, we're not going to expect you to do a lot with files. You're either going to read from a file, or you're going to write to a file. It will most likely be one of the two. In the case of sequential files, we might ask you to do both, but if we ask you a random access file, we don't expect you to do both. Input from the user into the record structure variables. Okay, you guys are overlapping. So will you get full marks if you got a doctor's handwriting on your design? How do you mean? I mean, just keep in mind, I need to be able to read what's on that piece of paper. There is this small clause. Let me just point the small clause out to you. Okay, it's not in this part. But there's a small clause we add to our papers. I'm pretty sure you would have seen it by now. Let me just show you. I can pull, and let's just pull one of these in. No, let's pull the main paper. A small clause will indicate that we need to be able to read. Unfortunately, it won't work. Because there is an instruction that says we need to be able to read it. If we cannot read it, we cannot award the marks. But if you can write like a doctor, you can just go and ask for your medical certificate so long. All right. Yeah, I know that was a bad joke. I know a lot of you are like rolling your eyes at the screen now. Okay. Are there any other questions right now? So on Thursday, if you're still concerned about random access, then we can go over that. I would recommend coming to Thursday's TUT. Just keep in mind we are still going to cover some work for Friday. So if there's just something you want to catch up on, obviously you've been studying, you've been practicing, you just like, can we just retouch on this specific point? I'm struggling with this, then we can do that. But obviously we'll have a plan for Friday, and we only have enough time to either do a sequential file or a random access file. So think about that, and then come and attend Thursday, or just download the stream and like skip through it to see what we covered. Right. Those that understand it will probably know what I meant with that. Let me just see if the audio is enabled. I'm not sure if it's enabled. Yeah, audio is enabled now.
Oh, sir, I meant like for the packet structure exam in that packet structure. Information like the ID, the subject, where within the we actually ask the user for that information.
You mean where did we actually define what the structure of the file is?
like for the ID, we have the it's been asked.
You're breaking up slightly. I'm not fully understanding your question. Can you maybe just say that again? Maybe I'm just not listening to it properly.
Can you hear me, sir?
I can hear you.
Oh, I meant like receiving information from. Oh,
You're breaking up again. Sorry, I can't hear your question. You're breaking up. Yeah, I'm really sorry. Can you maybe type out your question?
So I think he's saying like asking the user information. For example, like ID, the subject name, lecture name, number of students, etc. The ones in the record structure.
Oh, so the ones in the record structure was given to us. Okay, I closed that now already, but question A indicated that that DLL that we downloaded, that would have created the record structure for us, and then would have used a file that already has to populate that file with information. Basically, it's just going to give you the file that needs to that has that information already. So the file given to you already contained information for you to basically just prove that you can read from that specific file. Then you had the program which asked you for information. This part of the program is never actually saved to the file. You'll notice that the semester test question or the semester test is structured in such a way that it's basically a two-part practical. One part application, one part file. So you'll be able to code out the entire semester test without even having to touch the files. And then at the very end, do the files. And it's specifically structured like that so that students that are really struggling with files don't have to be too stressed about being penalized with that, because they can still do the entire application and test their application without their files actually working. So normally we'll either tell you to read from a file or tell you to write to a file. And if we tell you to read from a file, it will be to display it. If we tell you to write to a file, it will be based on the structure or the application itself. We'll tell you to write something specific from your structures into the file and potentially read. If it's sequential, if it's random access, it will just be read or write. It depends on the structure. Now, we are most likely going to put it at the very bottom. To be quite honest, we're still finalizing the structure. We're actually going to do it now after this lecture, or tomorrow morning, most likely tomorrow morning. So to write in a file is same as save. For sequential, you'll use the binary formatter, and then you'll just, file and then serialize. So serialize will write, deserialize will read, and with the binary formatter, with the binary writer, you'll just have binary writer dot and then read in the actual information you want to read one by one, that is. So the writer will read in the information one by one, and then when you read in the next record, you'll jump to that position and then read it in one by one again. The majority of debating on files or object-oriented principles. So I assume you have seen the past paper for 2019. So it's pretty much the same type of structure. So it will be, if you look at the mark sheet, this is paper A. Look at the mark sheet. you'll see that it is. So your file code itself will count about, let's see, this was random access, so you've got 10, 16, 21. No, 10, 16, 24, 32, 39 out of the 100, so about 40%. About 40% of the rack will be files. I say roughly 40%. Keep in mind that includes the hash function, and that's the correctness code as well. So in terms of actually writing code, it will probably be about 20 to 30%, and then you'll have about 10% correctness. Well, you'll have equal weighting correctness as you would have marks for that section. So 20 marks for the code, and then 20 marks for the correctness, most likely. That's generally the format. And we'll be sticking to that specific format. So it won't be more than 40% of the paper. That I can at least guarantee you. Well, we're still setting up the paper, so I guess not 100% guarantee it, but I mean, if you look at here, this one, if you have the same structure, you're looking at, let's see, 1, 2, 3, 30. Yeah, you've got 36 marks. So still less than 40%. So you won't see more than 40% for the files itself. I know a lot of students always stress about the files, and you really don't need to stress about it. It's not going to be that rough. I would love to tell you what file we are going to be using on Friday. Mr. Cottrell doesn't want me to tell you that. But that being said, the stream did go somewhat over time, by almost half an hour now, more than half an hour now, actually. And my screen just froze. Sometimes my screen just completely froze. I can't get back to the screen. So that is it for tonight in terms of the live stream. I just want to get back to that screen. I literally can't get back to my screen there. So there was a question about, okay, there we go. There was a question about Lucidcharts. So I'm going to stop the recording here. Those that want to stick around, just see what that's all about, you're more than welcome. But it's just an application for the design. It's something you'll be taught in your second and third year. But a student asked about it, so I'm just going to, did I miss a question? Supper time already, lol. No, that's not the question. So how would we store an array of record structures in a random access file? Once again, you need to know exactly what the record size is and then store them one by one. If you're unsure about that, maybe just rewatch the record file recordings. Double check there. If you still don't understand it by then, just send me an email or a Discord message in the channel, and then I can possibly do a recording on that, or we could just kind of meet on Discord so we can quickly go through that. Well, I say quickly, we can go through that. So just double check the recording. If the recording doesn't give you the answer, then just contact me and then we can set up a meeting so that I can explain it to you. I can try and use another example. If it's an extensive example, I'll probably record it and upload it for the entire class. Right. I'm going to stop the recording here because the recording is going to be long. But those that want to find out what Lucidcharts is, you can just stick around for a moment.